Good morning, everyone. Once again, welcome back to Shanabaseshwar College of Science. This video is from Mathematics Department, and I am your Mathematics lecturer, Jagadish. Okay, you guys already know we started your BSc 5.2 Laplace transformation classes, and in last class we discussed about your unit step function and definition of that unit step function and Laplace transform of unit step function. There is one derivation we see, and also we solved your property, that is second shifting property. Okay, so before going to today's class, we just once recap your previous class, that is unit step definition of unit step function and Laplace transformation of unit step function, the statement of that, and also we see the statement of your second shifting property. Okay, okay guys, in last class we studied your the definition of unit step function, and the statement of unit step function is the unit step function is denoted by u of t minus a. Okay, and it is defined by u of t minus a is equals to, they will get two values, one is 0 and another one is 1. 0 for when t is less than of a, and 1 for when t is greater than of a. That means wherever we get the a value, it means it's less than 0, then we will take 0 as a value, and when t value is greater than a, at that time we will take 1 as a value. Okay, and we also see on the theorem on Laplace transform of unit step function. Laplace transform of unit step function, that is your L of u of t minus a. Okay, wherever we will get Laplace transformation of this function, that means u of t minus a, you will get, that time we use the formula, that is e to the power a minus s divided by s. Okay, so this is your, we studied this property in last class, and today I am going to just explain the statement of this function. And one more we see your property number 6, that is second shifting property. So this is the important one. Second shifting property. So this property statement is, if Laplace transformation of f of t is equals to f of s, then we will get here two functions, that is f of t minus a and u of t minus a is equals to e to the power minus as into f of s. So this statement is, wherever we will get this function, that is f of t minus a and u of t minus a, on that time we use the formula e to the power minus as into f of s. Okay, and sometimes you will get only this function f of t, and this function you will get u of t minus e. Okay, on that time this function we have to convert f of t minus a, and this function remaining as it is, that is u of t minus e. Okay, so now we will see. Now we will see one example related to this property only. That is, find the Laplace transformation of t square into u of t minus 2. Okay, t square into u of t minus 2. That is, this function we will get as u of t minus a, and we want to become this one. This is f of t. So this function will convert it to f of t minus a, and the remaining function u of t minus a we have, and here a value is 2. That means you have to take this f of t minus a function also t minus 2. Okay, then only we will take your second shifting property formula. Okay, so now we will write the given equation, that is t square u of t minus 2. And when we apply the Laplace transformation this function, Laplace transformation of t square u of t minus 2. Okay, and we want to become this function, means this function we have to change f of t is equal to t square we have, and this function we will take it as f of t minus t. That is, here we have u of t minus 2 value, so this function we will take as 2. So this function I write here means t square I write here t minus 2 plus 2 whole square. So okay, so there is a no changes between this function and this function. So that's why I'll write this function. It is t minus 2 plus 2 whole square into u minus 2 as it is. And again this function I write here t minus 2 whole square plus 4 into t minus 2. When we simplify this function, we will get same only. And this remaining as it is u of t minus 2. And this whole function we will take it as f of t minus 2. Okay. So here we will get this whole function, we will take it as f of t minus 2. So here we will get f of t minus 2 and remaining u of t minus 2. And this is your second shifting property formula, that is u of Laplace transformation of f of t minus a into u of t minus a is equals to e to the power minus as into f of s. F of s means this is your Laplace transformation of f of t, that is this one. Okay, so here we will take it as Laplace transformation of f of t minus 2 u of t minus 2, and we know that your second shifting property, that is Laplace transformation of f of t minus a into u of t minus a is equals to e to the power minus as into f of s. And here we have a value is 2. Okay, so this function we will write it as directly, that is e to the power minus 2s into your remaining Laplace transformation of f of t function. Okay, f of t function. This is your function, and your f of t value is, and we will take just f of t function here. Here you will get your f of t function. So t minus 2 is equals to, we take t. So here we will get t square plus 4t plus 4. So this is your f of t function. So here e to the power minus 2s, your f of t function is, directly we take it as Laplace transformation of t square plus 4t plus t. And you guys already know Laplace transformation of t to the power n is equals to n factorial divided by s to the power n minus 1. Okay, this is your standard formula, and using this formula we will take it as e to the power minus 2s as it is, and this t square will take 2 factorial divided by s to the power 2 plus 1. This is 2 divided by s cube plus 4t, same it is 1 factorial, 4 into 1 factorial divided by s to the power 1 plus 1. It is 4 divided by s square, and this function remaining as Laplace transformation of 1 is equals to 1 by s. So here we will get have 4, and the answer is 4 by s. Okay. And here, when we simplify this term, e to the power minus 2s as we will take as it is, and the LCM of that function is s cube, and s cube we will take into 1 into s square. So this function we will write here as 2 into 1 2, 4 into s 4s plus 4 into s square 4s square divided by s cube as it is. and this s cube I'll write is outside. It is e to the power minus 2s divided by s cube, and this function I will write as a sequentially, that is 4s square plus 4s plus 2. Okay, so this is your required answer, and your final resultant answer is Laplace transformation of t square u into t minus 2 is equals to e to the power minus 2s divided by s cube into 4s square plus 4s plus 2. Okay, guys, sorry for the disturbance, and we will go for next problem, that is find the Laplace transformation of the okay, Laplace transformation of e to the power minus t cos 2t u of t minus pi. Okay, so here we will have the same property. Wherever you will get u of t minus a function, and in before we will get f of t. So this function we will convert it as f of t minus a. Okay, so here we have u of t minus pi, and this function we have to convert it as cos of means t minus pi. Okay, so first we will converting this function, and after that we will take your second shifting property formula, that is f of t minus a into u of t minus a. Okay, and this one is we have your property number 2, that is uh, e to the power minus as. This function will tends s tends to s minus a. Okay, so this function again we will take it as e to the power minus t is there, so s tends to s minus of minus 1, it is s tends to s plus 1. Okay, so now we will solution this function. First we will write the given equation, that is Laplace transformation of e to the power minus t, and I separate these two functions as cos 2t into u of t minus pi. Okay, and this e to the power minus t we will take it as s tends to s of minus 1 by your property number 2. Okay, so this function will call it as equation number 1. It is Laplace transformation of cos 2t into u of t minus pi, where s tends to s plus 1. Okay, and now we will take only this function. It is Laplace transformation of cos 2t into u of t minus pi. Okay, so this cos 2t we convert it as cos of 2 into t minus pi. Why pi only? Because we have here u value, that is u of t minus pi. Okay, so that's why we will convert it as t minus pi. Okay, so this cos 2t function I will write it as cos 2 into this only t function minus pi plus pi, that is 2 into t minus pi plus pi. Okay, so when we write this we'll get the same answer only, and remaining u of t minus pi as it is, and this Laplace transformation of cos this function again I will write it as 2 into t minus pi plus 2 pi into u of t minus pi as it is. Okay, so now this term we will take it as cos of 2 into t minus pi into u of t minus pi, where we will take, you know guys already, cos of theta minus 2 pi is equals to cos theta only, or we will take it as cos 2 pi plus theta is equals to cos theta only. Okay, so this type of function we will take it as 2 pi here we have, and this function will consider as theta. So this function will take cos of 2 into t minus pi into u of t minus pi as it is. So now you will get your property number. The property is that is second shifting property formula. It is f of t minus a into u of t minus a. And here we have f of t is cos 2t of t minus pi into u of t minus pi. That is our a value is pi. Okay, so now I will write it as cos of 2t minus pi into u of t minus pi, and this function I will take as your second shifting property formula, that is Laplace transformation of u of t minus pi into, sorry, f of t minus pi into u of t minus pi. Okay, and here we have f of t minus pi. We will take it as cos of 2 into, sorry, cos of 2 into t minus pi. Okay. Now the question is, sorry, our LHS side, that is Laplace transformation of cos 2t into u of t minus pi. This function we will write it as Laplace transformation of f of t minus pi into u of t minus pi, and the answer and your formula is Laplace transformation of e to the power minus as into your remaining Laplace transformation of f of t function. Okay, that is e to the power as, and here we have a value is pi. So this function I will write here, instead of writing this two total, we will write this function, that is e to the power minus pi as into Laplace transformation of f of t by your property, second shifting property. Okay, and now we have your f of t function is cos 2t, and this function remaining as it is, that is e to the power minus pi s. And you know already Laplace transformation of cos at. Okay, Laplace transformation of cos at formula is s divided by s square plus a square. Okay, so using this formula I will write here e to the power minus pi s as it is, and this function I will write it as s divided by s square plus 2 square. A value is 2, that is s divided by s square plus 2 square, and this function we will write it as e to the power minus pi s, e to the power minus pi s into s divided by s square plus 4. Okay, and your LHS answer is Laplace transformation of cos 2t into u of t minus pi is equals to e to the power minus pi s into s divided by s square plus 4. And you guys, you already know we have one more function is there, it is e to the power minus t, and equation 1 becomes, we will write it as equation 1, it is Laplace transformation of cos 2t into u into t minus pi, where s tends to s plus 1. We have equation number 1 we have, and this function we will write it as e to the power minus pi s into s divided by s square plus 4. Okay, wherever we have s, on that we will write s tends to s plus 1. It is e to the power minus pi into s plus 1 into s plus 1 divided by s plus 1 whole square plus 4. Okay, and now we simplify this function. It is e to the power minus pi into s plus 1 and s plus 1 divided by s plus 1 whole square e plus 4. Okay, when we simplify, and no need to simplify this function, we will write it as directly, it is s plus 1 into e to the power minus pi s plus 1 divided by s plus 1 whole square plus 4, and your final resultant answer is, it is Laplace transformation of e to the power minus t cos 2t into u of t minus pi is equals to s plus 1 into e to the power minus pi into s plus 1 divided by s plus 1 whole square plus 4. Okay, and you will get one note here, that is if we get two functions, that is if we get two functions here, That is f of t is equals to f1 and f2. Okay, f of t is equals to, we will get two functions, f of f1 and f2. f1 when t lies between 0 to a. Okay, t lies between 0 to a, and f of 2 t is greater than of a. Okay, and our formula is, and it is f of t is equals to, okay, when we'll get two functions, on that time we will take it as first one f1 of t into u of t minus 0 minus u of t minus a. Okay, so first function here we have to take a function, and this one we will write it as, okay, wait guys. Okay, here we have one note. It is if f of t function, we will get two functions. On that time, we will write it as the f of t is equals to first function f of t into your u of t minus 0 minus u of t minus a. This is first, plus remaining f2 of t, second function, into u of t minus a. Okay, this is your next formula, and we will see one example on this also. That is, express in terms of unit step function. That is, if f of t is equals to t square, where t lies between 0 to 2 and t is greater than 2. Okay. Okay, here we have two functions, that is f of t is equals to t and t square. T where t lies between 0 to 2 and t square where t is greater than 2. Okay, that means our a value is 2 here. Okay, in terms of unit step function, and hence find its Laplace transformation. Okay, the solution is, first we will write the given equation, that is f of t is equals to t square. First function is t, second function is t square. First function when the t lies between 0 to 2, and second function is for t is greater than 2. Okay, and according to your note, we know that your f of t function, first function, second function, and the first function is lies between 0 to a, and second function is greater than a. On that time, we will write it as f of t is equals to first function as it is into your u of t minus 0 minus u of t minus a. Okay, plus your f of 2 function as it is into u of t minus a. And here we have a value is 2. That is, f of t we have, f of t first function is t into u of t minus 0 minus u of t minus 2 plus f of f2 function is t square u of t minus 2. Okay, this you will write here same only. F of t is equals to first function t and remaining u of t minus 0 minus u of t minus a, that is a value 2, and plus second function t square into u of t minus a, that is t minus 2. Okay, when we simplify this function, we will get as t into u of t minus this function u of t minus u of t minus 2, and here also you will get t square into u of t minus 2. Okay, now we multiply this function. When we simplify this one, u of t u minus t of u into t minus t into u of t minus 2 plus t square into u of t minus 2, and here we have u of t value, it is okay. This function u of t will take it as 1, because of that you know t is greater than 0. It means this function we will take it as 1. We will write it as t into 1 function, and here we will take u of t minus 2 as a common outside, and remaining t minus, sorry, this function will take first time t square minus t here. Okay, this u of t minus 2 we will take as common outside, and remaining t square minus t, this function as it is. And you guys already know u of t value is 1 for t is greater than 0. That's why we'll take t into 1, and this function we will write it as t plus t square minus t into u of t minus 2. Okay. So now we apply this function to Laplace transform, that is Laplace transform of f of t is equals to L into Laplace transformation of t first function plus t square minus t into u of t minus 2. Okay, here we will get same only, it is f of, we have to take it as f of t t minus a, and remaining u of t minus 2 we have. Okay, now we separate this function. Okay, we your property number first, that is Laplace transformation of u plus, sorry, x plus y, we will take it as Laplace transformation of x plus Laplace transformation of y. So here we will take it as separately, first function Laplace transformation of t plus your remaining second function, that is t square minus t into u of t minus 2. Okay, so this is your Laplace transformation of t. You guys already know Laplace transformation of t is equals to t to the power n is equal to n factorial divided by s to the power n plus 1, and here we have 1 is n value, it is 1 divided by s square. So this function we will write as outside, and remaining this function we will take as same as your previous one, that is this function we have to convert into f of t minus a. Okay, and this function we have already u of t minus a, that means u of t minus 2 we have. So this function also we have to convert into f of t minus 2 only. Okay, because of that you have here u of t minus 2, a value is 2. So this function we will convert it into Laplace transformation of this t square, will take it as t minus 2 plus 2 whole square minus this function minus t into, sorry, remaining minus t minus 2 plus 2 this function. When we simplify this function we will get same only, that is this function will get cancelled, this function will get cancelled, here t square minus t only, and remaining u of t minus 2 as it is. So this function will again, with this function we will write it as t minus 2 whole square plus t minus 2, and this function we will take it as plus 4 minus t minus 2 minus 2. Okay, so simplify this function, we will get same only, and remaining u of t minus 2 as it is. So this whole term we will take it as f of t minus 2, where f of t minus 2 is equals to t minus 2 whole square plus 3 into t minus 2 plus 2. Okay, and remaining this one as it is, u of t minus 2, and you will get your property, second shifting property formula, that is Laplace transformation of f of t minus a into u of t minus a is equals to e to the power minus as into Laplace transformation of f of t. this 1 divided by a square function as it is, plus this function we will take it as Laplace transformation of f of t minus 2 into u of t minus 2, and this function we will write it as directly e to the power minus 2s, e to the power minus 2s, because we have a value is 2, e to the power minus 2s into Laplace transformation of f of t as it is. And we have your Laplace transformation of f of t function, Laplace transformation of f of t function here. Here we have your Laplace transformation of f of t function. We'll take f of t is equals to f of t minus 2. That means wherever we have t minus 2, we will take it as t. It is t square plus 3t plus 2. Okay, this is your f of t. So we'll write it as 1 plus s square as it is, plus e to the power minus 2s into Laplace transformation of t square plus 3t plus 2. Okay, so you guys know already Laplace transformation of this formula, t to the power n is equals to n factorial divided by s to the power n plus 1. That is, we have here t square first function, 2 factorial divided by s to the power 2 plus 1 first function, that is 2 into s cube, remaining this function 3 into 1 factorial divided by s to the power 1 plus 1, that is 3 divided by s square, and this function 2 by s. Again here we will take it as s cube as a common outside, and this function into 1 into s square. Okay, so here we have 1 divided by s square plus e to the power minus 2s divided by s cube, and this function we will write it as 2s square plus 3s plus 2. Okay, so this function we will write here 1 plus s square, 1 divided by s square plus e to the power minus 2s by s cube into 2s square plus 3s plus 2. Okay, so your final resultant answer is Laplace transformation of f of t is equals to 1 by s square plus e to the power minus 2s divided by s cube into 2s square plus 3s plus 2. Okay, and similarly we will get your 3 function. It is Laplace transformation of f of t. Okay, similarly you will get your 3 functions. That is f of t is equals to 3 functions. It is first one f1 of t, second f2 of t, and third f3 of t. Okay, first f1 of t, when t lies between 0 to a, and f2 for t lies between a to b, and f3 where t is greater than b. Okay, and this time we have same formula. First we will take f of t is equals to f1 of u of t minus 0 minus u of t minus a. Okay, this is your first function, plus f2. Same, f2 is u of t minus a minus u of t minus b, plus f3. f3 is equals to u of t minus b, u of t minus b. Okay, this is your third practical. When we will get third 3 functions, instead of writing 1, on that time we will write f1, f2, f3. Okay, suppose we will get f4 one more function here. That means we will take here, it is here minus u of t minus c plus f4 u of t minus c, last one. Okay. So your we will get third functions here. That time we will write here f of t is equal to f1 of t, f2 of t, f3 of t. f1 where t is lies between 0 to a, f2 where t is lies between a to b, and f3 where t is greater than b. On that time we will write here f of t is equals to f1 of u of t minus 0 minus u of t minus a plus f2 of u of t minus a minus u of t minus b plus f3 of u of t minus b. Okay.